Hey everybody. Well, by the way, it's beautiful out here in the desert. Um, so here's my thing. I was looking at the answer that you gave for the question of the moving ladder, and really I loved it. You had insights. You had whether you gave right, some of you gave right answers, wrong answers, but what I'm more, I guess what means more to me personally, two things. One is the thinking process, and I saw your brains were really like moving a lot. Um, in this, what I have to say is a thought-provoking question. And the other thing I saw was just I guess how do I say this? The kindness and regard that you and respect that you had for each other was really just beautiful it was beautiful to see that aspect. So let's dig into this. I want to show you the moving ladder. So I'll tell you right now, spoiler alert, it is not a constant rate. Eh. Now let's see what that means. Let's just let me move to my other screen. Okay, I'm sharing my screen with you, and here we go. Boing, boing, boing. Why is it not sharing? Boing. Maybe I'll have to click this thing. Okay, there we go. Sharing the screen. So a 20-foot ladder is hold on one second, please. Let me just pause this. A 20-foot ladder is leaning against the wall, period. A troll is moving the bottom of the ladder away from the wall at a constant rate of 2 feet per second. Consequently, the top of the ladder is sliding down the wall accordingly. So the question is, does the ladder top also descend the wall at a constant rate? The troll is going at a constant rate of 2 feet per second. Is the wall going at a constant? Is the part against the wall going down at a constant rate? Uh, if so, is it the same constant rate? Is it also 2 feet per second? Maybe it's a different constant rate. Or maybe it's not a constant rate at all. These are the possibilities. This is really what I want you to think about it. This is what I want you to think about. This is what I wanted you to think about. What being in the hot desert, maybe it's tying my tongue a little bit. What now? Of course, what does this have to do with calculus? And calculus is all about rates of things and things changing and stuff like that, and relative rates. That's what we have right here because we're looking at the bottom of the wall versus the top of the wall. So it's a relative, get it, related rates. So what is this? And what does this have to do with section 2.11? That was a huge hint. So I'm going to switch cameras again. First, I have to get rid of my virtual screen. For some reason, when I when I switch to my document camera, I cannot have any of the any of the funny, cool, fancy backgrounds. I just have to have a plain no background. That's just the way it works. I don't know. Otherwise, when I put on the document camera, you see the background instead of seeing what's on the piece of paper. Okay, now let's go. Boing. So here we are. So let's get a look at this question here. Um, okay, I don't need to share my screen. You all know the question. I mean, I don't need to share the question. You all know the question. So here's the story. I'm looking at So some of you very astutely and very correctly said, you know something, I think Pythagorean theorem is going to come and play here. And you were absolutely right about that. Definitely Pythagorean theorem. And let's see why that is. Let's see why that is. So here's the situation. This is the wall, this is the floor. I'm going to say floor, and this is the ladder. Now the ladder is 20 feet. That's not changing. The troll, uh, oh, I don't know how to draw a troll. I think they have like ears or something. Not sure exactly how to draw a troll. Um, so the troll is pulling the bottom of the ladder, and he's going at 2 feet per second, and the ladder is 20 feet. Now we have here the wall. I'm just going to call it W. Now W, when I say W, I mean the side of this right triangle, this leg of the triangle, and when I say uh, the troll is standing on the floor, we're going to say floor. I'm going to use F for floor. So the floor is increasing at a rate of 2 feet per second. Meaning, if I look at this triangle, just think about the triangle. This leg, the bottom leg of the triangle, the floor of the triangle, if you will, is increasing at 2 feet per second because of the troll. The hypotenuse of the right triangle stays the same. The question is, what's going on with this third the vertical side of the triangle, or the vertical leg of the triangle. So many of you correctly realize that Pythagorean theorem is going to come in here. So let's take a look. W squared plus F squared equals 20 squared. And of course, 20 squared is 400. Even I could figure that one out. And now what we want to do is we want to look at rates here. So we want to take the derivative of each side with respect to time, not respect to x, but respect to t, respect to time. I just have a lot of respect for time. I see what I did there. So we get here 2w times the inner derivative, dw dt, plus 2f, that's the outer derivative, times the inner derivative, df dt, equals 0, because the derivative of well, 20 squared, whatever it is, it's just a constant. The derivative of that constant is 0. And I'm going to simplify it a little bit. I'm going to, well, I'm going to simplify a little bit. I'm going to divide everything by 2, because I like things as simple as possible. So I have w times dw dt, and that's what I want. dw dt, by the way, that's the rate at which this length is changing. So I want to find that rate. So plus f times df dt, but df dt, we're given that that's 2, and is it positive 2 or negative 2? Well, f is increasing, so it's positive 2. And that equals 0. So now solving just a little algebra, solving just the algebra here, I get dw dt equals, let's see, negative 2f over w. And again, I brought the 2f. That's not f of 2. That's f times 2. That I brought the 2f to the other side. It became negative 2f. I divided everything by w, and I got this right there. So what does that mean? What does that tell me? Well, it tells me that this rate, the rate of the ladder going down, or the rate at which this length is diminishing, or changing, I should say, is negative 2f over w, which means it's going to change every second, every time f and w change, because f is getting bigger and bigger as the troll moves away, and w is getting smaller and smaller. First, now before I say another word, is it surprising that I got a negative answer? Remember, f is the base of a triangle. It's a positive thing. It's this base, this length on the ground. W is a length on the wall. It's a positive thing. So this is negative. So 2f over w is positive. Negative that is negative. Is it surprising that we got a negative answer, or is that weird or surprising? Think about it for a second. I'll pause the tape and tell me what you say, or tell yourself what you say. But I'm going to tell you. Pause. Okay, time's up. The answer is not surprising at all, because since w is decreasing, it makes sense that I got a negative answer. If I can move it like that, just a little, got that down. Since w is decreasing, because it's descending, so it makes sense that dw dt is negative. Let's analyze further. How does a fraction get bigger? A fraction gets bigger when the top gets bigger and when the bottom gets smaller, right? If I have a fraction and I make the top bigger, the fraction gets bigger. If I have a fraction, I make the bottom smaller, the fraction also gets bigger. Now, in this case, it's a negative number. So when f increases, I get a bigger number. And similarly, when w decreases, I get also a bigger number. Now, what's happening is the troll pulls the ladder. Both of those things are happening. F is increasing, W is decreasing. So what's happening. So that means I get a bigger and bigger negative number, which means the ladder is descending faster and faster and faster as the troll pulls the ladder away. Let's actually put some numbers to this. Let's look at what happens. Let's consider what happens when, oh, I don't know, let's say the ladder is 12 feet away. Let's look at what happens. Let's look at case one. F equals 12. So in that case, that's 12, that's 20, and by Pythagorean theorem, that's going to be 16. So dw dt is going to be negative 2 times 12 over 16, which is, what is that? That's let's see, divide by 4, divide by 8, I get 3. That's 3, negative 3 over 2, which is what that's negative 1.5. What 1.5 what? Well, feet per second, because this whole because once we're in the units of feet and seconds, everything stays in that unit. Okay, now let's look at case two. Let's say the troll is now 16 feet away, so he's further out. Little troll. So the ladder is 20. That's not changing. It's not a stretchable. It's not a stretchy ladder. It's a let me draw a little right angle here. So that's 16. Now by Pythagorean theorem, this is going to be 12. So dw dt in this case is going to be negative 2 times 16 over 12, which is, let's see, that's going to be 4 and negative 8 over 3, which is what's negative 8 over 3? That's 1.66. Negative 1 point. Is that right? Negative 8/3. Let me just make sure. I don't want to say the wrong thing here. 8/3 is negative 8 divided by 3. Just, yeah. Oh, I'm sorry. 2.6. Negative 2.6. I'll say negative 2.67. Notice and of course again feet per second. Notice that it's a bigger number, which means that the ladder is decreasing, is going down faster. So the question was, will the ladder descend at a constant rate when the bottom is being pulled out at a constant rate? And the answer is a resounding no. And we saw that with calculus. And I'll let you guys think of the physics of it or the physicality of it. We see with calculus that the ladder is going to decrease more as the top of the ladder is going to descend faster as the bottom gets pulled out further, and that is it's not a constant rate at all. And that is what is happening, and so you see, we can learn from everywhere and from everyone, even from trolls. Okay, everybody, this was wonderful, and I'll see you next time. Bye.